Okay, for finite math, for Module 1, what I want to do is talk about set theory. Now, in your textbook, and I'll be referring to the 7th edition of Finite Math by Rolf, but some of you can just change the page numbers. It doesn't make any difference whether we're working with the 5th, 6th, 7th, or 8th editions. First thing you got to understand is about sets is how do we write them? We've got three ways of listing out sets, okay? And I'll give examples of that. But first of all, the most important thing is what is a set? And in non-technical language, a set is a bunch of something that you know what is in the set and what is not in the set. That's probably the most general, bland thing you've ever heard mathematically. But the key here is there's got to be a rule or a definition. What is in my set, what is not in my set? Because the key is the set sets the world up as a dichotomy. You're either in it or you're not in it. Okay? A dichotomy means you break everything up into two, like on or off, yes or no, or whatever. In this case, are you in the set, yes or no? So, three ways of listing the set. One is you list all of the elements. Okay? You got the curlicues on the outside, 1, 2, 5, 6, 8. Okay? I'm using numbers, but this could be letters, could be anything. It could be pieces of furniture, could be anything at all. People, names, you don't care. It's a concept as far as what's in my set, what's not in my set. In this case, I listed. This set has 5 items in it, 5 different items. And they are 1, 2, 5, 6, and 8. Now, I could write it that way. If I've got a set that goes on and has a lot of things in it, like this one, 1, 3, 5, 7, 9. You notice that's the odd numbers. Rather than listing, those go on forever. I can put a dot, dot, dot. That tells me, take the pattern. So I have to list enough items so you can see the pattern and then continue it. Now, if this set finishes in dot, 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 that means we're looking at an infinite set. Those dots go on forever. Look at the next example, 2, 4, 6. That's the even numbers. I got my dot, 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 and I got a 20 there. What does that mean? That means this is a finite set. It starts, it's the even number, starts with 2, and it goes to 20. So I could write it out just like this one. It would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay? It would have 10 elements in there, and those would be the list. So instead of writing the whole list out, I could do it this way as a shorthand. The third way of writing this out is the more formal mathematically, and unless you're going to be taking a serious math class, you probably won't see this very often, but they write it this way. The set of A such that A is equal to 3n plus 1, where n is your counting numbers. In other words, what? Put in 0 for n. 3 times 0 is 0 plus 1 is 1. So 1 would be in there. Put 1 in there. 3 times 1 is 3 plus 1 is 4. Put 2 in there. 6 and 1 is 7. Put 3 in there. You get 9 and 1 is 10, etc. You see the pattern? 1, 4, 7, 10. The next number would be 13. The number after that would be 16, 19. In other words, these are increasing by 3. Okay? And this is a way of writing it. That's all we care about, that is we have that you can write these things in 3 different ways. Now, what else you have to do is consider, how do I work with these? Let's take an example. I'm going to give you 4 sets. If A is 1, 3, 5, 7, and 9, in other words, the odd numbers between 0 and 10, okay? The odd 1-digit numbers. Then the next one is the even ones. Then I've got C is 1, 2, 3, 4, and D is 3, 5, and 8, okay? Just to keep this simple. Now, first thing is intersection. Intersection, that upside down U, means what is in both sets. In other words, what do I find in both sets, or what is common to both? Well, A intersection D. If I go back to here, A is 1, 3, 5, 7, 9. D is 3, 5, 8. Well, 3 and 5 are in there. So I would say that the intersection of A and D is 3, 5. What's the intersection of A and C? A is 1, 3, 5, 7. C is 1, 2, 3, 4. The intersection of that has 1 and 3 in it. Okay? What if I string together A and C and D? Really, look at these two. What's common to both of them? Just the item 3. So this would only have 3 in it. What we're saying is 3 is the only thing that is in all 3 of those sets, A, C, and D. And you'll see that there's a 3 in here, 3 in here, 3 in here, and nothing else shows up in all of them. Okay? A and B intersected. Well, if this is odd and this is even, there's nothing the same. So the way we write that is the circle with a line through it. This is not 0. This is the null set. In other words, the set of nothing. If I was writing it down in terms, this is like this. There's nothing in there. Not 0, because 0 is an element over here. It's part of B. Okay? So the null set is not 0. Now, next thing is intersection. That's the letter D. A intersection D is what is in A or in D. So I go back to A. Well, everything in A is going to be in there. 1, 3, 5, 7, and 9. D has 3, 5, and 8. So 3 and 5 are already in there. I add 8 in there. So my answer would be 1, 3, 5, 7, 8, 9. If I intersected A and C, I'd add 2 and 4 in there. So I'd have 1, 2, 3, 4, 5, 7, 9. A intersection B, the odd and evens together give me everything, 0 through 9. And what's the next one? Okay, not A. Well, if I'm talking about single digits where 0 through 9, if A is 1, 3, 5, 7, 9, what's not A? It's the stuff that's not in there. 0, 2, 4, 6, 8. If my universe is 0 through 9, then A is 1, 3, 5, 7, 9. Not A is 0, 2, 4, 6, 8. And you see that it also turns out to be the same thing as B. So I could say B is equal to not A. What is not C? Okay, look at C. 1, 2, 3, 4. Well, what else is there in my universe of one-digit numbers? There's 0, 5, 6, 7, 8, 9. So not C is that. Okay? So, and the not C is called the complement of C. And so what we're talking about there is the other stuff. Okay? And if we refer back to these, in your book they will talk about N of A. In other words, the number of items in A, the number of items in B. Well, remember, if A is 1, 3, 5, 7, how many things are in there? 5. How many things are in B? 5. How many are in C? 4. D has 3. Now, how many things are in A intersection D? Well, A intersection D was 3 and 5. There are 2 things in there. Similarly, A intersection C, if you look at these things, this is how many elements are in the set. Okay? And how many elements are in these things. Now, the important thing to look at this is if I take 2 sets. If I take A and C, there are 5 items in A and 4 in C. If I add those 2 together, I've got 9 items. So if I merge A and C, the most I could have would be 9 items. But do I have 9 items? It depends. If I double counted anything, then I don't have it. So you look at the number of items in A and C is 7. I double counted 2 items. Look at it. A and C, how many double countings? 2. But this leads to an interesting relationship. You don't say 4 and 5 is equal to 9. When you merge 4 and 5, when you add them together, it could be 9, but it's 9 minus how many things you double counted. Or another way to look at it is the number of things in a union is the number of things in each set minus the number of things that were double counted. Or you could put it this way. The number of things in the union plus the number of things in the intersection, the double countings, is equal to the sum of the size of the 2 sets. think of that again. A and C. I got 5 and 4. Okay, so I got 9 things total. How many do I have in both sets? 2 of them. So that means when I merge them together, I'm going to have 7 things, because there are 7 different items plus 2 that I double counted to account for the 9. When I merge the sets, I can never get more than 9, and I can't have less than 5 because there are 5 different things in A. If all the stuff in C was the same, then I would merge them and I'd have 5. I'd have 5 plus 4 is equal to 5. If they're all different, I'd have 5 plus 4 is equal to 9. In this case, there are 2 items together, so 5 and 4 merged together give me 7, which is telling me that I got 2 double counted, because the 7 and the 2 will equal the 9. Okay? How about counting not A and B? Is that the same as not A intersection not B? No, it isn't. Let's look at it. What is not A intersection D? If you remember from the example we had before, was 3, 5. Okay, so not 3, 5. So I'm going to get 0, 1, 2, 4, 6, 7, 8, 9. Okay, what's not A? That's 0, 2, 4, 6, 8. What's not D? 0, 1, 2, 4, 6, 7, 9. Right? Because thinking back to what my A and my D was. Okay, when I unite them, well, when I take the intersection of those, what's in both? 0 is in both, 2 is in both, 4 is in both, and 6. So I've got 4 items that are in both. But when I did it the other way, when I took the intersection first and then the complement, I ended up with a much bigger set. So you look at this. The not does not pass through these nicely. Okay? We will look at that later on, but be careful on this stuff. Okay? The symbols you don't fall in love with. You just got to make sure you understand and check everything out with simple examples to see how it works. Anyway, so that's what we have. A set is anything that you know whether it's in or not in. I've got 2 operations, union and intersection. Okay? And they're written like this. This is union. And this is intersection. Okay? And I use capital letters for sets, so I'd have A union B. What does that mean? That means all the items that are in A or in B. So this thing means the same thing as the word or. The intersection means the word and. And this is where you're going to have to reprogram your head. You think of and as meaning added. The or is where we're adding. The and means you've got to meet both things. It's a restriction. Okay? So the union is all of the stuff that shows up in either set or in both. The intersection is only those items that show up in both. And so if I combine 50 items in one set with 20 items in another set, taking a union, it's merging them together, the most I could end up with would be 70 items. Okay? If I had 50 over here and 20 over here. But I need to know how many are in the intersection. In other words, how many did I double count? If the intersection has 10 things in it, that means 10 of these were already in there. So when I merge them together, this is going to have 60 items in there. Because the 60 and the 10 will add up to 50 and 20. That's the relationship that exists between this. And that's all that we have for Module 1. Thank you.